Hello everyone, welcome back to another video of the Winter Forest. Today we are going to continue leetcode challenge. Today's challenge is called the kth smallest element in a BST tree. So here the given example. Let's look at the first example. The first example say you have this root and this tree. Then you look in the first smallest. In here you could find it is 1. And then second example tell you, so you're going to start with the looking for the third smallest number. In here you could obviously see is 3. So how to achieve this one? They have a 2 way to achieve it. And anyway, 2 way all use in order this tree. So the first we are going to use a stack. We are going to in order up to case number. Then once you found the case number, just break the loop, then return it. So I need to know the position. So the position in here, it is I need to return this 3 out. The first thing. The second thing, I need to have a stack. Just put this in order 1, 2, 3. So the smallest in the stack bottom. And the second way going to do it is the binary search. So you actually just only keep 2 elements in array. First is remember the position. Second thing is compare which one is compare with the value with the 3. Let's use the first example. By the way, in here he noted the case is between 1 to BST. So what does this mean? It means this definitely won't be nullable, and the k will be positive, and in this between you don't need to do nullable check. Just let's move into how to do the code. So if we go iterate, just looping up to case array. So I'm going to have array in order the number up to case number. So then we have are going to need to remember the position. So in which position I'm going to find it. Once I found it, I could simply just return the array position -1. I didn't type in position. And we're going to start a search. We're going to have a stack. Tree node. We start looping it. Instead of change the node, we're going to copy this one. So this load actually is equal to this node. So we're going to while loop it. If the stack is not empty or load is not equal to null, we start our loop. First time coming in, the stack is empty, but our load won't go into empty. I'm going to use this one pointer to this one because I'm going to keep updated the load. But why the load not equal to now, we keep moving to the left because the left is the smaller one. We're going to put the smallest one in the stack first. So we're going to push the load to the stack. Then with the load equal to load.left. Until up to the left finish, we start popped up because left is the smallest one. Once we pop, every time we pop, we're going to check the position. Copy in case I type in. If this position is smaller than the k, we're going to update the array, the current position 0, for example, is 0 position to the node.value, and afterwards we plus, just +1. Else, if you already found that, you just break the loop. Here, not break the if condition, it actually is break this loop. Then you're going to return. Once in the left, you loop the finish, you do exactly the same thing. Load equal to load.right. So this will do the trick. So let's test this, see if could finish satisfied. Have a compile error. Yeah, load.y missing semicolon. Array position. I think I better copy paste. I should suppose typing short. 30, 32, 32. Yeah, typing ish. Yeah, it is satisfied. Let's submit it. Basically, what I just go through it. What I do, so I'm going to have an empty stack. First, I have a load pointer to this one. I keep looping to the left until I find that the left is smaller. Then I start to pop up. Every time I pop up, I see if this is smaller than this one, because this already the smallest one. So if this case value already it is what I'm looking, then I just break the loop. For this example, going to update the value equal to this one and plus, see if in here, see if break or not. Update the value to this one and plus 1, see if 1 smaller than k or not. 0 become 1. No, 1 is not smaller than k, then you pop it out 2, and then update the load value stacked in, then the position plus become and 2 become 2, still not in, and this one 0 1 0.1, then in here is 2, go here is 3 non small and not smaller than the k. So in this time this will break, in this loop going to break, so you won't go into the right, then going to stop. If we not break, if we need go to right, for example, if he looking so like this value, then you go into the right, then you pop it up, then you going to find it, everything. And this then we use a literary search, but actually you could use a binary search because tree only have 2 left and right. So basically the idea is still over there. So instead of stack everything, we just do another example, binary tree. So I only need to remember 2 positions. So I'm going to have an array. I'm going to have an array only contain 2 elements. Only remember, and in the end, I'm going to just hold the first position, and in the end are going to return this array the 1 position. So you only have the 0 and the 1, so you will break at the 1 position. And what are you going to do? You just in order the tree. So you basically just in order the tree, you pass the root, and you give you only contain 2 elements. Once the second element satisfy, you just break this loop. So actually this in order going to don't need a return. So going to private void, just copy paste in case I type in. I'm going to accept a tree. And I'm going to accept this array. This array only contains 2 numbers. And this is the case I'm going to find, because since it is a binary search, you only need to go left and right. In here, once you go into the root, until you loop finish, it will be finished and then empty. So you just simply just return. Otherwise, you're going to compare this array 0. The same idea previous already commented, delete. So this one, even if this one equal to k plus equal to k, because you only hold the position, the action. So if this it is, then you put then one value equal to root.var, and then you here you just finish the loop, and then you if this you didn't find it, then you go into the actually you go into in order left first. In order left first. So you in order left first. Then this is your array. Then the k. Once you in order every time, because you're going to find the smallest one in order left, then you compare this one. Then you in order you right. This also can do the trick. So exactly the same, the code looking simple. Actually this the speed not very faster than the previous one. Afterwards. So let's test it. Oh, missing semicolon in here. Have a companion. I'll just say I have a number. Damn it. Right. So this array, actually maybe name is number more makes sense. You only contain 2 numbers. Yeah, it is similar like use stack to do it. Actually exactly the same. So you are always in order the tree, but in this element you only remember the they need to find the one under the previous position, and if once you loop into this position, this remember the position. The second one is remember the value. So you're going to once this one plus equal to this one, it means you already found it. So you put the value. This load actually is the value you're going to find it. So you need to remember 2 things. One is the position, one is this value. So you just only remember 2 things. This look like more easy make sense because you just go travel left first, see if you find it. If you don't find it, just you travel right. Let's submit it. Say it is accepted, but see if you have a report. This is the accepted report. Doesn't show previous report. This report shows you are in runtime in here. It actually 0 minutes ago. Yeah, it is last. Never mind. They say you are runtime 100% of Java submission. It is very fast. Yeah. Both way all very good. Thank you for watching.